Guys, welcome back to my channel on TD Made Easy. If you're new on this channel, please click on the subscribe button and turn on your notification. In this video, I'm going to show you how to draw an auxiliary plan. But before I go into auxiliary plan, you need to understand the principal views in orthographic projection. We have 6 principal views, and these views are top view, which is also called the plan, and you can see the top view in blue, the front view in green. When you look straight on in the direction that is given to you, you get this views. So when you look towards your front, you get the front view, which is in color green. Then when you look towards your right side, there are 2 sides to this block. We have the right side and the left side. So when you look towards your right side, you will see the yellow view, yellow, yellow, and yellow. So now the left side, you can't see. The left side is hidden, same as the rear view. The rear view is also called the back. The back means the rear. So the bottom view is also hidden. So the 3 main views that you can see are the top view, front view, and the right side view. So from here, let's see what auxiliary view is. From the word auxiliary, auxiliary means helper. An auxiliary view is a type of orthographic projection. It is used to determine the true shape and the true size of a surface. It can be inclined surface or oblique surface. So when you follow through the line of sight, you get the auxiliary view. So it's basically used for inclined surfaces, and it gives you the true shape and the true size. So let's see the example we have. The figure below shows the plan and the elevation of a hexagonal pyramid. Draw an auxiliary plan looking in the direction of arrow P. To draw an auxiliary plan, there are basic principles you need to follow. As we're looking at auxiliary plan in this video, in my next video, I'm going to show you how to draw auxiliary elevation. So for an auxiliary plan, you project from the elevation. You can see that it's vice versa. I want to draw auxiliary plan, so I need to project from the elevation. Number 2, I will take measurements from the plan. And number 3, I'll take my shape from both sides, both the elevation and the plan. So step 1, draw the given view the way it's been given using the measurements. You draw the elevation and you also draw the plan. Step 2, label the plan and elevation as shown. Label the plan and the elevation as shown. So I have A, B, C, D, E, F, and center O. A, B, C, D, E, F. That gives me the 6 sides because it's hexagonal pyramid. It's hexagonal. Hexagonal, X means 6. So I'll move my AB to this point, CF to this point, and ED to this point. It's just like you merging the edges together. When you merge this point and this point together, it gives you AB, just like what I have here. When you look at this shape, you see that the plan is still fully represented. A, B, C, D, E, F. This is A, B, C, D, E, and F. And this is the apex. The apex is O. The apex is quite different from C and F. So the apex is another point on its own. That's why it's here and it's labeled as O. Then I have the sixth side. I want to count the sixth side. This is side 1, 2, 3, 4, 5, and 6. So now I want to follow the principle that I stated earlier. I said you project from the elevation. Because we are drawing auxiliary plan, we need to project from the elevation. So this is the elevation and this is the plan. So how do I project? I need to project following the direction of the given arrow. The given arrow is towards the side. You can be given inclination of angle. You can be given angle 30 degrees. You can be given inclination of 45. You can be given inclination of 60. So whatever is given to you, you follow the inclination. Whatever is given to you is what you use. And if the angle is not stated, just follow the direction of the arrow. So you can be given any inclination, be it 30, 40, 50, 30, 45, or 60. So now I want to follow just the direction of the arrow. So now this is what you need to do. You bring out your set square, place it by the side of the inclination. Here we are considering 4 points on the elevation. This is 1, 2, 3, and 4 points O, AB, CF, and ED. So I'm projecting my lines from this point, following the direction of the angle of inclination. Now I've placed my set square on the arrow given to me, that is the inclination given to me. So from there, using my ruler to balance the set square, I can move my set square from there, take it to ED, that is the first one. I'll project my line. I'll take it to CF, following the parallel line. I'll project my line. From CF, I'll take it to AB. I'll project my line. Then I'll take it to the last point, which is O. I'll project my line. You can see that in all this, I'm still using, I can still go back to the inclination. Step 4, mark the plan width as F, AE, O, BD, and C. The first principle is to project from the elevation when you're drawing the auxiliary plan. Now, I need to take the plan width because I want to draw the auxiliary plan. If I'm drawing the auxiliary elevation, I'll take the measurement of the elevation, but I'm drawing the auxiliary plan, so I need to take the measurement of the plan. So I want to label this. I'll project lines from each point. From C, I'll project a horizontal line and name it as F at this point, which is the same as AE. This point is point AE. I'll project a line. From O, which is the center, I'll project a line. BD, I'll bring out a line. And at point C, I'll also bring out another line. Okay, so now we need to transfer the plan width to the auxiliary plane. So how do we transfer the plan width to the auxiliary plane? In order to do that, You bring out your ruler. Take the measurements. That is principle 2. Take the measurement of the plan, which is the plan width. So I'm going to take it from O to the next point, which is AE. I have 1.5. From AE to F, I also have 1.5. If I try to confirm from O to BD, I have the same measurement, which is 1.5. Then from O to BD, I have, from C to BD, I have 1.5. So altogether, I have 6 centimeters. So now I need to transfer the plan width to the auxiliary plane. So now, to start with, you need to draw a perpendicular line on the auxiliary plane. The perpendicular line is the reference line, which is the XY line. So I'm going to place my set square and make sure the set square is making 90 degrees with the line, the parallel lines. So now, my set square is making 90 degrees to this line. So from there, I can bring out my reference line. Right, so next thing is to transfer the width. To transfer the width, I'll use my ruler. You can as well use your compass to transfer the measurements. So I'm going to transfer it at intervals of 1.5. So I'll mark 1.5. This is the starting point 0, then to 1.5. The next one to 3. 4.5. And the last point, 6. With this, I can draw my lines. This is the first line, which is line F. At 1.5. One point five. All right, since I'm starting from the reference line, I'll name this as F. AE. Line O. O is the middle. BD. And the last point, C. Okay, so I've been able to transfer the plan width from the plan to the auxiliary plane. So the next thing to do is to connect the point of intersection. Connect the point of intersection. When you trace from this point, this line is line O. So I will asterisk where I have O. I'll move on to the second line, which is line AB. So I will asterisk anywhere I come in contact with A or B. So I'll keep moving. This is F. When I get to this point, this is A. Move on to this point, this is O. Come to this point, I have my B. So the last point is C. There is no connection. I'll move on to the third one, which is CF. This line is line CF. So I'm going to asterisk anywhere I have F and C. So this is F. This is AE, no connection. This is O, no connection. This is BD, no connection. This is C, there is connection. The last point is point ED. I'll trace point ED. This is F. This is E. There is AE, so I can connect with E. This is O. There is no connection with ED. This is BD. Yes, there is connection with D. And the last one, this is C. No connection. So when you look through this point of intersection, you will see that already we have the shape. We have side 1, 2, 3, 4, 5, and 6. That gives us the hexagonal B. So let's see the third principle, which says we need to connect. When you're connecting, you can take the shape from both the elevation and the plan. So I'm going to start with F. I can connect my F with A. So when you go back to the plan, you can see that F is connected to A. F is also connected to E. So I can draw my lines using connecting F. I want to connect F to A. Now, looking at the other side, F, is it connected to E? Yes, we can confirm this, that F is connected to E. So I've joined F to point E. This point is point F and this point is point E. Okay. This is point E. Is E connected to D? Yes, E is connected to D. When you look through the plan, you see that E is connected to D. So you join it together, the straight line. And is D connected to C? D is connected to C. So I'll join it together. The next point, C, is it connected to B? This is point C, and this is point B. They're connected. Then is point D connected? No, point B, is point B connected to E? Point B connected to A. This is point A. So we are going to see it from here. Point B is connected to A. So I'll join it together. Good. Now, when you look at this, when you look at O resting at the center, you can see that A is connected to O, B is connected to O, D is connected to O, E is also connected to O. So I'm going to pick it one after the other. This is A. A is connected to O. So I'll join it to O. The next one is B. B is also connected to O. So I'll join it together to O. Then when you look at this point, this is point F. Is F connected to O? Yes. Point F and C, they are connected to O. So I'll join F to O. And I'll also join C to O. Remember I told you that you take your shape considering the plan and the elevation. So I've been using the plan, now I move to the elevation. C and F connected to O. So now when you look at this part, this point is point D. D is also connected to O. So I'll join this with a thick line to O. And the last point is E. E is connected to O. Now you can see that we've been able to get the shape, the hexagonal pyramid. But when you look from this direction, there are some parts that we should use broken lines for because they are hidden. The only part that you can see when you are positioned at this point is F, E, D, C. The remaining part, which is C, B, B, A, the remaining points, C, B, B, A, and A, F, should be represented with thin short dashes. So I'm going to break my lines. Okay. So I'm going to show you from this view. So now when you look at it, you will see this is hexagonal pyramid. The part that is visible to you, they are just 1, 2, and 3. The remaining parts, the remaining 3 sides are hidden, and you can get it from here. These are the parts that are hidden 1, 2, and 3. Let me go back. 1 at the back, 2, and 3. So at the front view, you can only see 1, 2, and 3. The remaining 3 behind, they are also hidden. The remaining 2 lines at the back are also hidden. So let's see the lines at the back, 1 and 2. So this is how to draw an auxiliary plan.